All right, just had to get myself kind of organized there for today. We're missing a few people here, kind of a small class this morning, but we can make it work, no problems. Hopefully, there's not too many Blackboard Collaborate issues happening. I had a lot of issues going on yesterday, so knock on wood, if I have any around me. I don't really. Hopefully, today goes a little bit better. All right, so as you can see, I do have an announcement up on the board there regarding the upcoming deadline. So the third quarter is quickly coming to an end. Technically, if I take a look at the calendar, I want to say March 29th is the last day of third quarter. I'll just take a look here. Oh, April 2nd, it says, is the end of quarter three. But March 29th is that last day before our spring break. And I'll use spring break in air quotes because not sure if you can call 2 days off a spring break. But what I would like is to have, just to keep things the same as they've always kind of been, keep that Sunday deadline of April 1st. I know that's an Easter Sunday and it's April Fool's, but if we can keep that Sunday deadline, hopefully that'll be a little bit better for our organization. And what has to be turned in by April 1st is everything from semester 2 up to and including 8.03. Obviously, you can see today we're looking at 8.02, and in Thursday's class, we'll be taking a look at 8.03. So I don't really see it being a problem for you guys getting everything up to that point handed in by that April 1st deadline. There shouldn't be any issues with it really by that time. So just want to give you guys a forewarning there. If you have any missing assignments or late work, that needs to be turned in by April 1st. And most of you in here are just fine and have absolutely nothing to worry about. And if you're following along with the pace of the calendar, you'll automatically have that stuff handed in. Nope. There's no midterm test. I do not do anything special for midterms. I simply just pull a grade. So whatever grade you have in your grade book, that's the score that you'll see kind of on your report card. So there's nothing special as far as midterms go with tests and whatnot. Okay, good. Any other questions with that? All right, you guys are really awesome with getting your work in, so I'm not too worried for you guys there. All right, then our plan for today is to continue looking at our next conic section, which are ellipses and circles. Woohoo! Now, when we take a look at this next conic section, there will be some equations and information that I want you to copy down in your notes. Again, we will start with things centered at the origin, 0, 0, so you may not want to copy down that block of information, but when we get to our center being somewhere other than the origin, that's the information that you're probably going to want to jot down. So you may want to hold off for a little bit on writing your formulas down until we get to the one where the center is at h comma k and not 0, 0. All right, so here's our definition of an ellipse. So we can see some diagrams here with things labeled, and we've got our nice chart there. Again, this is an ellipse centered at the origin of 0, 0. Now, we did talk about, or I did mention previously, that our ellipses and our circles were going to be looked at with the same equation. So if we do have a circle, we would still use the information that we have with an ellipse. The only difference between an ellipse and a circle is that the major axis and the semi-minor axis have the exact same value, right? In an ellipse, you will not have the same value for your major axis and your minor axis. Obviously, that major axis is the one that's a little bit longer, and the minor axis is the one that's a little bit shorter, right? In a circle, those two values are the exact same. So if A and B are the exact same number, you can multiply through by that. So hypothetically, I take this an equation for an ellipse, and A and B, or A squared and B squared, are your 4. You can multiply through by that 4. And now over here, instead of a 1, you'll have an integer value, and that integer value is your radius squared, right? So we're looking at a circle with radius 2 in my example down below. So there are slight differences with what you can do with that formula if you are looking at a circle than what you could do if you were looking at an ellipse. So when we focus on our ellipse, our equation must equal 1. But if it's a circle, we can multiply through, and that 1 will then change to that radius squared portion of it. Any questions with how we can transform the equation of our ellipse here into that equation for our circle? So it's just a little slight added step there to get rid of the fractions under the x squared and y squared and kind of have that radius squared on the other side there. Correct. Yep, and a circle will only be identified if A and B are the exact same value. If A and B are not, then it will automatically classify as an ellipse. Yep, so if A and B are not the same value, it's automatically going to fall into that ellipse category. All right, you're also going to notice the Pythagorean relation at the bottom. The Pythagorean relation now appears because if you see, we have those right triangles over here, and we have that C value that is taken from the foci. So here's that focus, and if I were to drop down a side here, we can create a right triangle within that ellipse. So this is where that Pythagorean relation comes into play. This Pythagorean relation does change for different conic sections. So we definitely want to make sure that we're writing that down in our chart to constantly be looking back on, because it does change depending on the conic section we have. So for an ellipse, we use a squared equals b squared plus c squared. And you can see where the a, b, and c values come from in the two setups of the ellipses over here. Okay, now this chart you do not need to copy down quite yet. Notice that it is just centered at 0, 0. I would recommend copy down the chart that has the h comma k, because even if you have just h comma k and it's still centered at the origin 0, 0, the chart for h comma k will still work for you. Right, so if you want to save some space in your notes, maybe hold off on writing down that chart quite yet. All right, let's dive into an example. It says find the vertices and foci of an ellipse. All right, so I take a look at the equation they give us in example 1, and it's 4x squared plus 9y squared equals 36. How can I get this equation to look like one of my choices up here so that I can start pulling values for A, B, and C and identifying those different pieces of information? So what do you think we can do? Yeah, the first thing I notice is it doesn't equal a 1, right? And I think Tommy had that same instinct there as well. So if it doesn't equal a 1, you've got to get it to equal that. So we're going to divide by 36. And to keep things balanced, we divide everything by 36, not just one term. Okay. From there, we can simplify 4 over 36. What does 4 over 36 simplify to? 1 over 9. Good. What about 9 over 36? What will that simplify to? 1 over 4. And 36 divided by 36 is our 1. All right, so now we took that equation that they gave us, we did a little bit of work with it, and it looks like one of the equations we have up above. Which column should we focus on? So here comes that killer question. Which column do we focus on when we want to pull information now? The first, yeah. What gave it away with the first column? The X was what? The X and Y placement. And here's how we have to decide the X and Y placement, because technically there's nothing stopping me from moving these two pieces around, right? Oopsie. If I were to move those around, Y comes first, X comes second, would I use the second column then? Because addition is commutative, so if I swap those places, would I have to use the second column? No, I still use the first column. So you're correct with the X and Y placement, but what's so important about the X and Y placement? What are you truly looking for with the X and Y placement? Maybe not where it falls in the equation, but instead, you're looking for what? Which is over A and which is over B, right? A should be your larger value, right? So we're kind of used to that A being the larger value because A represents the major axis. So if A is larger, that should come first, right? And X squared is over that larger value. So if X is over the larger value, that is column 1. In column 2, Y is over the larger value. So we would use column 2 if that were the case. All right, now that we know we're looking at column 1 and for that particular reason, let's go ahead and find the vertices and the foci of the ellipse. In order to find the foci, we need our values for A and B so that we can find C. So let's start with our value for A. What do you guys think A is going to equal in our equation? 3. Yeah, you're going to take that 9, which is equal to A squared, and take the square root of that to find your value of A. What's the value of B? Yeah, you take whatever is underneath the Y squared, the square root of that. Square root of 4 is your 2. All right, then we're going to go ahead and use the Pythagorean relation to help you find C. So A squared was 9, B squared was 4. What will our C value equal? Square root 5. You got it. Now with these ellipses, and even kind of moving forward with our hyperbolas coming up as well, it's not uncommon to have square roots in our answers, especially when it comes to your foci part. All right, let's start with the vertices. What are the vertices of this ellipse? Plus or minus 3. Yep, so that means there are 2 points. Isaiah's beat me to it. Whenever you have that plus or minus, that means there are 2 points for that scenario. A negative 3, 0, a positive 3, 0. All right, then let's go ahead and find those foci next. plus or minus square root 5. Yep. And again, that is two distinguishable points. A positive square root 5, 0, and a negative. Now, when you guys are writing your answers on your assignments, you can do the shorthand version and just do that plus or minus route. So like I think Tommy had done it for the vertices and then Rachel did it for the foci there. You can go ahead and do that shorthand approach. I have no problem with you condensing your answer as just a plus or minus a comma 0 or plus or minus c comma 0. If you want to write the two separate because it works better for you personally to see them separated apart, that's okay with me as well. So if you're like Isaias and want to write and Tommy that second time around and you want to write them separated, you can do that as well. Okay, any questions with how we got the answers here? So a little bit of work to get there, especially rewriting the equation first of all, and then finding those values for A, B, and C. So any questions there? All right, let's venture forward. All right, nothing ventured, nothing gained here. So the next equation says find an equation of the ellipse with your foci at 0 plus or minus 3, whose minor axis has a length of 4. It does say to sketch the ellipse. We're not going to sketch the ellipse. We will rely on GeoGebra if we need to graph anything. So at any point in this unit, if we're asked to graph or sketch something, we will go back and rely on GeoGebra to help us with that. Although theoretically, we have all the information we need to be able to graph it by hand. Once we know the major and minor axis, and once you know where the center is at, you should have no problem constructing that ellipse by hand if need be. All right, let's go ahead though and see which column do I need to be focusing on if my foci are located at 0 plus or minus 3. Yep, we're focusing on the second column this time because the y value of our focus is the one that's changing. All right, so if we're given the focus, that means we have a value for C. What does the value for C equal in our setup here? Three. All right, what other information can I pull from our example? There's one other piece of information. We can pull the value for B. What is the value for B? 4. All right, yep, it says the semi-minor axis is that B. So if the minor axis has a length of 4, B will then be our 4. We can use the Pythagorean relation here to find A. So let's step off to the side and do that. A squared equals B squared. Let's change that to an equal, not a plus, right? I'm so used to writing the actual Pythagorean theorem there. All right, A squared equals B squared plus C squared. So when we work backwards there, what will our value for A equal? 5. All right, so now we technically have everything we need to write our equation. We'll start with the y squared. What is going to be our A squared then underneath there? 25, yep. Then we'll do x squared. What's going to come under x squared in our equation? And we'll have that equal 1. Beautiful. All right, not too bad as long as we have that chart as a guide, right? Be a little bit more difficult without that chart because there's a lot of information to remember from all that. All right, now that we have some practice with it centered at the origin, here's the chart that I would recommend writing in your notes. Here it is with your ellipses at the center H comma K. All right, remember the center is where your minor axis and your major axis intersect. So that's essentially where the center is occurring in our drawings. So when you have that minor axis and you have the major axis, where they intersect is going to be your center now. All right, notice that the formula changed ever so slightly. Instead of having just an x and a y squared in the numerators, now you have x minus h and y minus k. The h is always attached to the x, and the k is always attached to the y, right? That's the only thing that has changed with our equations here. We do have an extra added piece in here because I'm not sure if they talked about the focal axis on the last one. If they did, I may not have paid attention to it. I apologize. But that focal axis there is going to be like a horizontal or a vertical line through H and K respectively. Other than that, most of it has stayed the same, right? The only difference with that foci and vertices is that instead of having it at plus or minus C plus or minus A, you have that H in front of it and then the K at the end. All right, let's see. So while you're continuing to write that down and add it to your notes, let's work through an example here, just so we don't lose too much time today. And you're going to notice that I have this chart on every single slide. So every single slide will constantly be looking back at it. So if I go too fast and you don't have it written down, don't panic. It'll just be on the next slide for you to continue writing. All right, it says find the standard form of the equation for the ellipse whose major axis has endpoints at -2, -1, and 8, -1, and whose minor axis has a length of 8. All right, so here I included the diagram to go along with that information. Here are the endpoints for the major axis, and there you can see the minor axis also graphed with the length of 8. Now we can pull a value automatically. Which value can we pull based off that information? There's actually two pieces of information you can pull. You just got to work a little bit harder for one of them. If it says the minor axis has a length of 8, what does that mean? So if the minor axis has a length of 8, that means B equals 8. Okay, and I wrote B equals A. I meant 8. Yeah, and then Isaiah says he just counted the spaces or used that distance formula to help him identify A, which is going to be 10. Good, so technically all you have to do is the distance formula in here or count the spaces since it is a horizontal line. All right, we technically don't need C at all to write an equation, but we need to identify what column we're looking at. So here's the tricky part. Which column should we use to write our equation? It's a little bit tricky, right? Any ideas? There's only one kind of major giveaway with it. It is the first. How did you know it was the first? And it could have just been a guess, but what made you guess the first column? Hey, that's really good. A is bigger. Nice. Yeah, A is bigger, which means it goes under the X. The other thing was your focal axis. So the focal axis should be falling on that major axis, and the major axis was a horizontal line. So a horizontal line is going to be y equals some number, right? All right, the only other thing we need to actually write our equation is the center now. So we need to find h and k. So we have to use that minor axis and major axis as a guide because we're looking for the intersection of those two axes. So what's the intersection of that major and minor axis? Yeah, so if I take a look, 3, -1, they kind of did the work for us. Now, they knew to place this minor axis right in the middle of your major axis. So your minor axis should bisect your major axis. That's how they knew to stick it right at +3 for the x value, because it splits that major axis into 2 equal parts then. So that's what we want to happen, and that's how they knew to place it right here. So if I take a look at that, 3, -1 is going to be our center value. All right, now I'm just going to go ahead and use substitution to pull my equation. So we're going to do x minus h squared all over a squared plus y minus k squared. Notice I have a minus a negative, so that turned into my +1 there, over b squared equals 1. Good. Any questions with how we got that final answer? So that was a fun first one there for us. So we used the focal axis, which is going to be our major axis, to tell if it should be the first or second. Yeah, so that is just one thing that you can use. I do like how you identified that A is larger than B as well. Although that didn't really help us like what should come in front of it. Because A is always technically going to be listed first in both equations. But if that, I think that focal axis just kind of solidifies it there. So the focal axis is horizontal in this case because that's what your major axis was. It was horizontal. So that's how we knew to pull from column 1. Okay, I saw it typing and then it disappeared. So if there's still questions with that, obviously let me know. I'm more than happy to scoot back here to that problem and address any of the concerns that pop up with it. But Isaiah, yes, you are correct with your statement in the chat box there. It always should be. I don't think that we will ever run into an example where it's not. Yeah, so cross that off our worry list, right? Phew, kind of dodge a bullet with that one. Yeah, we won't have any ellipses that are kind of turned or twisted at all. Rotated, I guess, would be the correct mathematical term. We won't run into any of those scenarios. No. They'll either be horizontal or vertical for your focal axis. Yeah. All right, now let's see if we can go the other way around. If we have an equation, can we pull information from it? So first of all, which column of information should we be looking at or focusing on for this? Pay attention to the A value. That's really going to be the kicker. So Tommy thinks the second column, Isaiah is going to second the second column. Rebecca's going to third it. Yeah, when we take a look at which number is larger, 49 is larger than 9, right? 49 falls under the y, so that means a squared must be under the y. All right, let's pull the values for h, k, a, and b, and then we'll work backwards to find c as well. Let's start with a. What will a equal according to my equation? 7, right? Because that's the square root of your 49. What will your b value be? Yep. What will h be? Yeah, remember h is always attached to the x, so that's your -2. So glad you guys did the opposites there. And then what will your k value be? Yeah, 5. Woohoo! When you're pulling h and k, don't forget to do the opposites from inside those parentheses. All right, we do need to find c still, but we can use the Pythagorean relation to help us do so. So we'll get our a squared equals b squared plus c squared. So what will c equal here? Yeah, nice simplification. Square root 40, which then simplifies to 2 square root 10. Yeah, nice simplification. If you want to use that square root 40, there's nothing wrong with that, but at this point in our mathematical careers, we should use the simplified radical, so that 2 square root 10 is a nice answer there. All right, we can go ahead. We have everything we need. Now we just need to put it to use. So finding the center, well, that's our h comma k. We technically already did that. That's at 2, 5. Now we need to find the vertices. All right, what are my vertices going to be this time? So h, and then k, plus or minus a. Now here, we probably should identify the two actual distinct points. If you have that 5 plus or minus 7, that's a basic arithmetic there. You can easily identify the two separate points. So we'll have -2, 12, yep, and -2, -2. All right, the foci, now the foci uses that square root value, so this is where we can maybe leave it condensed instead of separating it into the two distinct points. Let's check out the foci, so that's your h, comma k, plus or minus c. So because we have that plus or minus 2 square root 10, we can leave it as the one value here. But just note that that is two distinct points. 5 plus 2 times the square root of 10 and 5 minus 2 times the square root of 10. Okay. Any questions with how we got our answers for that information? All right, the eccentricity, we don't see this too often, but in case it makes an appearance, you might want to just write down the formula real quick for an eccentricity. If the eccentricity of an ellipse can be found by using c over d, it looks like, but to put this in terms of what we already know, we're going to go ahead and do that square root of a squared minus b squared all over a. So A is your semi-major axis, B is the semi-minor axis, and C is the distance from the center to either focus. Again, we don't work too much with eccentricity at all, but in case that term pops up, we know how to find it if need be. Most of the time, I'd say 95% of the time, we focus on the vertices, the foci, and the center, and then actually writing our equations. Okay, and that again is just in the textbook as well, so if you need to pull it, you can at any point in time. It's also in the online lesson too. All right, let's get a little bit more practice here. I'm just taking a look at what we have all left and let's do this one instead because it has to do with completing the squares. Woohoo! All right, so we need to find the center, vertices, and foci of the ellipse given by the equation there. All right, so because I kind of gave it away a little bit, to get our equation of our ellipse, we do have to do a process called completing the square. We did that with one of our parabolas, but here we're going to do it twice. One for the x value and once again for the y value. So what we're going to do to write this equation in the standard form is we're going to kind of separate the x's out from the y's. So I'll leave a little bit of space there. I'll separate the y's next, and then we'll want to move that constant to the other side. All right, so all I did was kind of space things out a little bit there between the x's, the y's, and I moved the constant. Now, before we can complete the square, we need to factor out a little bit from the x's and then a little bit from the y's, because in order to complete the square, we want there to be a 1 in front of this. So for there to be a 1 in front of the x squared, we've got to take out a 4. Okay, any questions with what we did there with that x portion and factoring out the 4? Okay, I'm going to take it one step at a time. We'll complete the square for the x's first, and then we'll go back and repeat the process for the y's. All right, to complete the square, we take half of the middle term. What is half of the middle term here, or half of -4? -2, and we square it. What is -2 squared? 4. All right, well, whatever we add to one side, we've got to add to the other to keep it balanced. If I added 4 here, what do you think I should add to the other side? It seems like we want a 4, but it's actually not. We want to add a 16 to the other side. You're probably thinking, what? Where did she get 16 from? Where did I get 16 from? Yeah, we've got to take into consideration the factor we took out in the beginning. So whatever we add here, we do want to distribute that to that outside term. So 4 times 4 is technically a 16. We added a 16 here. We need to add a 16 on the other side to keep it balanced. All right, to actually factor that then, that breaks down into x and then whatever half the middle term was. So that's going to be a -2 squared. All right, let's do that same tactic with the y's. So what do I want to take out as my GCF for the y's that I have left? I'm going to take out a 9. If I take out a 9, that leaves me with the y squared plus 2y. Let's go ahead and complete the square for that. What is half of the middle term squared? 1, yeah. Half of the middle term is 1. 1 squared is 1. So if I'm adding 1 there, what should I add to the other side? A 9. Good. We aren't going to fall for the mistake twice, right? So we're going to go ahead and multiply by that GCF to add the 9 on the other side. All right, while I factor the little y piece here, let's add all those constants we have on the other side of the equal sign. So what do we get when we add all those together? $36. Yep. All right, this still does not look like our standard equation because it doesn't equal 1, it equals a 36. But we actually did an example like this already. What's my last step I need to do to put this in the standard equation for an ellipse? We got to divide by the 36, yep. And then we will just kind of simplify our different pieces from there. So that will be our x minus 2 squared over 9 plus y plus 1 squared over 4 equals 1. Perfect. We now have this in our standard equation, and now we can start pulling our values for a, b, and c. Let's start with our value for a. What will a equal in this equation? 3. What will b equal? 2. And we got to figure out what c is going to be as well. So coming up here, 9 equals 4 plus c squared. So it looks like it's going to be that square root of 5 again, huh? Very similar to the first one we had. All right, we do need h and k though, because I also need that for my vertex, my foci, and my center as well. What is my value for h? So when I pull information for the center, what is going to be my value for h and k? 2, yep, for h. And what is our k value? -1, yeah. So we just found the center by doing that. The center is located at 2, -1. Which column should I be pulling from for the rest of my information then? Should I pull from column 1 or column 2? Column 1, yep, the first column. Yep, because that a value is under our x. All right, so we got the center. C should be your square root 5 because when I work backwards up here in that Pythagorean relation, if a is 9, a squared is 9, and b squared is 4, 9 minus 4 is 5. And 5 will equal the c squared. So I have to take the square root of both sides to get my value for c there. All right, sounds good. Got the error figured out. Next, we're going to pull the vertices. So following column 1 here, my vertices are at h plus or minus a, comma, k. So what do 2 distinct points are my vertices happening at? 5 and -1, -1, -1. Yeah, just forget that second -1, but that was just a typo there. All right, the last thing is our foci. So the foci is happening at h plus or minus c, comma, k. So this one I'm going to just leave bunched together because it has that square root sign. So 2 plus or minus the square root of 5, comma, -1. But there are 2 distinct points there. So again, don't mistake that for just being 1 point. There are 2 that you can separate that into. Okay, good. Questions with that at all? Okay, you guys did pretty well. I think as long as we have this chart to look back on, you guys should be just fine with your 8.02. All right, we didn't get through everything today, but that's okay. You should be able to still have no issues with the questions from the homework. Obviously, I will start Thursday's class off with any questions that you may have ran into from lesson 8.02, but I'm not expecting there to be any like red flags that pop up or anything in that meantime. So you guys should be good to go. And then in Thursday's class, we'll take a look at 8.03, which I believe will be our hyperbolas. So one more conic section to kind of zone in on there. And we'll look at that on Thursday's class. All right, that's all I got for you today, so I'll let you go. Have a great rest of your Tuesday, and I'll see you all Thursday again. Bye, everyone.